Microsoft's Power Platform is heavily marketed to citizen developers, but beneath the drag-and-drop interfaces lies a complex data infrastructure requiring professional software engineering. The Microsoft Certified Power Platform Developer Associate exam, or PL 400, serves as the formal validation for developers moving into extensibility and custom code. The testing parameters are strict. Candidates face 40 to 60 questions in exactly 100 minutes, requiring a minimum score of 700 to pass. Traditional developers often approach the certification with a specific bias. Because Power Apps relies on low-code tooling, there is an assumption that the exam will primarily test Maker portal navigation and basic UI configuration. The reality is much heavier. The PL 400 rigorously evaluates a candidate's ability to implement custom client-side scripting, write server-side C# logic, build external API integrations, and manage complex application lifecycle management. To understand what is actually required to pass, we need to look past the isolated bullet points of the syllabus. We will map the 6 official exam domains onto a single, unified system architecture. Approaching the exam as a list of independent facts leads to failure. A developer must adopt a systems architecture mindset, understanding exactly how the front-end components talk to the Dataverse backend and external services. This diagram represents the core of our architectural model, the server-side backend. This maps to the exam domain known as Extend the Platform, which carries a massive 30 to 35% weighting. Because of this immense weighting, this single domain dictates whether a candidate passes or fails. You cannot compensate for weak backend understanding by mastering the UI. Here, developers write custom C# Dataverse plugins to extend logic, requiring a precise understanding of the event execution pipeline. The exam tests your ability to interact with the execution context, specifically utilizing pre- and post-images. These are snapshots of data taken immediately before and after a core database operation, allowing your plugin to compare state changes and execute conditional logic. Moving beyond plugins, the exam requires developers to perform operations using the Dataverse Web API and the organization service, ensuring data can be manipulated securely from external sources. When server-side operations exceed the 2-minute timeout limit, candidates must know how to offload processing to Azure functions. The test specifically asks how to configure these Azure functions using scheduled triggers, and how to authenticate them securely back to the Power Platform using managed identities. This heavy emphasis on back-end execution pipelines and Azure infrastructure proves that Microsoft positions the Power Platform as a robust enterprise backbone. The exam ensures you can engineer highly scalable back-end solutions, not just set up a simple database. We now pan up from the back-end to the front-end UI block. This layer encompasses 2 domains: extend the user experience, weighted at 15 to 20%, and implement Power Apps improvements at 10 to 15%. Historically, developers extended interfaces using HTML web resources. The PL 400 demands proficiency in the modern alternative, the Power Apps Component Framework, or PCF. Unlike those older web resources, PCF code components render as part of the exact same context and load concurrently with native components. This eliminates the disjointed performance issues of iframe embedding. There is a critical licensing trap heavily tested here. If your PCF component connects directly to external services through the user's browser, rather than through a native connector, the app becomes premium. Every end user will then require a standalone Power Apps license. Beyond custom visual components, candidates must know how to write JavaScript that targets the Dataverse Client API object model to apply business logic directly to forms and views. When that logic fails, the exam requires you to diagnose the issue. You must understand how to use browser-based debugging tools, specifically Monitor, to trace application events and identify bottlenecks. For Canvas apps specifically, you are tested on performance optimization techniques, such as preloading data and ensuring large datasets utilize query delegation to push processing work back to the server. The strict focus on PCF integrations and query delegation demonstrates that front-end Power Platform development requires the same rigorous state management and performance considerations as building a custom React application. Zooming out to view the entire system, we introduce the horizontal pathways that connect Dataverse to the outside world. These represent develop integrations at 5 to 10% and build solutions, which covers deployment at 10 to 15%. A system cannot operate in isolation. The exam tests the mechanics of publishing Dataverse events outward and consuming external events inbound. You must know the exact configurations required to register service endpoints, routing Dataverse execution context data to webhooks, the Azure Service Bus, and Azure Event Hubs. When managing external databases, you must understand data synchronization. The exam tests how to enable change tracking on tables and utilize alternate keys to match records without knowing their internal Dataverse IDs. This culminates in the upsert request message, which efficiently synchronizes datasets by either updating an existing record or inserting a new one in a single operation. Finally, all of this logic must be deployed safely. Application Lifecycle Management, or ALM, requires candidates to manage complex solution dependencies and environment variables across development, test, and production tenants. You will be tested on creating continuous integration and continuous deployment pipelines utilizing Power Platform build tools within Azure DevOps or GitHub. Success in ALM and integrations translates to the ability to maintain interconnected, enterprise-scale systems. This complete architectural diagram serves as the ultimate visual study matrix for the PL400. It visualizes exactly how the 100% exam weighting is distributed across a live system. The profile of a passing candidate is clear. They are a developer fluent in C# for backend plugins, TypeScript for front-end PCF components, and Azure for service integrations. Memorizing leaked exam dumps is an extreme hazard. Not only does it violate Microsoft's assessment policies, leading to banned credentials, but it completely fails to teach the systems thinking required to actually do the job. Preparation should focus strictly on the official Microsoft Learn modules and gaining practical experience by building solutions inside a hands-on developer sandbox environment. To test your conceptual understanding, rely on scenario-based practice questions. These challenge your ability to apply architectural logic to complex problems, rather than rewarding rote memorization of interface menus. The PL400 validates the application of rigorous software engineering principles to a low-code environment. Earning the PL400 demonstrates the technical proficiency required to engineer highly custom, scalable solutions that extend the native capabilities of the platform.